Okay, so if you look down straight at the top of this, what would you see? Okay, so you're going to see a triangle. And then you're going to see this coming like this, here, here. Where this middle point, that point right there where they all meet is going to be the tallest point. So that's going to be the closest to you. This line down here would be the furthest. This line would be the furthest. So it's like all coming up here to this point. Okay, if you were to look straight down at the top of this, what would you see? You'd see a square, a rectangle, whatever that is. Okay. If you look straight down at the top of this, you're going to see a pentagon. And you're going to see this coming up. Yeah. Something like that, coming up to this point right here. And if you look down straight at the top of this, you're just going to see a hexagon. Okay, so today what we're continuing doing is just thinking about three-dimensional figures and being able to think about what's going on with them. All right, so as you can see, what I took was just these. This is the same thing we just had on our warm-up. Okay, so what shape is this right here? Okay, this is a triangular pyramid. This is a triangular pyramid. And we're going to definitely talk about the difference between those two, I believe, tomorrow, but I'll go ahead and say now. Okay, the difference between a pyramid and a prism, the second one is a prism, is that a pyramid only has one base, and it always has triangular faces.
So that one would be a prism.
This one's a prism because this one has two bases, and it has rectangular faces.
Oh, nice. So that one's a pentagon something. Pyramid.
Oh, yes, that's right. Okay, now we'll get to those in a second. What we're going to focus on today is thinking about faces, vertices, and edges. Okay? Faces, vertices, and edges. So, where is a face, or what is a face of one of these three-dimensional figures?
Oh, well, all of them.
Okay, so a face basically is going to be a plane, is any of the planes. Now, we'll start making the distinction between faces and bases, actually even today, but for what we're doing right here, when I say faces in this context, I just mean any flat surface on there. Okay, so V stands for vertices, or that's just plural of the word vertex. Where's a vertex at? Okay, a vertex is where two lines meet up. In other words, it's where there's a single point. Okay? And then where's an edge? Okay, it's a line. It's where two planes meet up. So on this triangular pyramid, how many faces are there? There's 4 faces. Okay? There's the front one, the 2 on the back, and then the bottom one. Now, how many vertices are there? There's 4. There's one here, 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 and here. Okay, how many edges are there? 6. There's 1, 2, 3, 4, 5, 6. All right, what's this one? Okay, so we're going to just say, since we don't really know, okay, a rectangular prism. Rectangular prism. All right, how many faces does it have? 6. It's got the top and bottom, the front and back, and the left and right hand faces. So it's got 6 faces. How many vertices does it have? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many edges does it have? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, what is this one? One of those words. Whoa, pentagonal pyramid. How many faces does it have? It's got how many? 6. It's got the 5 going around and then the one base, which is, like I said, in this context, we're considering a face. So it's got 6 faces, 6 planes, 6 flat surfaces. How many vertices? 6. There's 1, 2, 3, 4, 5, 6. How many edges? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. What is this?
That's a hexagonal prism.
Yep, this is a hexagonal prism. Okay, again, the way you can tell the difference between these two, like for instance, back to this pentagon up here. Okay, on this pentagonal pyramid, it's a pentagonal pyramid because it has a pentagon for a base, but you can tell it only has one base. Okay, here, this is a hexagonal prism, and you can tell it has 2 bases. Okay, because the hexagons are the bases, there's 2 of those. So that's one major difference between a pyramid and a prism is that pyramid only has 1 base, prism has 2. And on a pyramid, you have these triangular faces. Here on a prism, you have rectangular faces. All right, so how many faces does this have? It has 8. The top, bottom, and then the 6 going around. How many vertices? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many edges does it have? It's got 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
That one looks kind of fun.
Yeah, this one is a little bit funky.
A regular octagonal pyramid.
Okay, well, yeah, we'll go with that. Although I think we'll leave out the word regular because this side definitely looks like it's a different length than this side. So we have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so octagonal pyramid. How many faces? 9 vertices and edges. 16. All right, one more here. What's this? Okay, triangular prism. Faces. 5 vertices. Edges. None. Okay, I think you get the idea there. Okay, let's turn it over, and this is going to go back to what we did in our last unit, and this stuff is going to show up again in this unit, is we need to know how to find the area of just 2-dimensional shapes, because that's going to show up a lot. All right, so again, this is just kind of review of what we did in our last unit. So how do we find the area of this triangle? Okay, base times height divided by 2. So it's going to be 6 times 9 divided by 2. What does that give you? Okay, so we get 27 square meters. All right, how do we find the area of a circle? Pi r squared. 2 pi r is for circumference. Yeah. So pi r squared, pi times 3 squared. 6.27 square centimeters. Okay, how do we find length of a rectangle? Length times width, base times height, however you want to say it, 6 times 10, or 10 times 6, which obviously is 60. Okay, what's this thing? Parallelogram. How do we find every parallelogram? Base times height. So on this one, it's just 8 times 12, which is what? 96 square feet. All right, number 5. What's this? Trapezoid. How do we find the area of a trapezoid?
Why do you
Okay, because what you're doing is you're averaging the bases. Because if you left it base 1 plus base 2, you would be doubling it. And so what you're doing is basically, this is another way you could write it, is base 1 plus base 2 divided by 2 times the height. That'd be the same thing. What you're doing is you're adding this base, and then you're averaging it. Okay? So you're cutting it in half so that you know, for instance, this would be the same thing as a 6 by 6. Okay? Which, so you know this is 6 by 5, and that's going to give you 30. I mean, I guess I could give a more elegant answer than that, but that's basically what's happening. Okay, so we're going to have 8 plus 4 times 5 divided by 2, which is going to be 30. All right, triangle, base times height divided by 2, which is 35 square meters. Okay, on this one we've got a regular polygon here. These 3, 7, 8, and 9 are regular polygons, or we're going to assume they are. So how do we find the every regular polygon? Apothem times the perimeter divided by 2. Okay, so how long is the apothem on this one? 6.84. How long is the perimeter? Is what? Okay, how do you know it's 47.4? Okay, good, because perimeter is adding up all these edges, so you have 7.9 plus 7.9 plus 7.9 plus 7.9 plus 7, so whatever. So 7.9 times 6 gives you that. So we're doing the apothem, 6.84 times the perimeter of 47.4 divided by 2. 162.11, I think.
Oh, yeah.
There you go. Okay, go ahead and find the arrow number 8 and 9 real quick. Sounded pretty serious. Golly. All right, so number 8, how long is the apothem? 11.42. What's the perimeter? 77. So we're going to do 11.42 times 77 divided by 2. What does that give you? 439.67. All right, and then 6.76, and then so 44.8. Is that what you said?
Yeah.
Okay. So then 6.76 times 44.8 divided by 2. What does that give you? 151.42 square inches. All right, so pi times 7 squared is 153.94 yards squared. 12 times 12 is 144 square centimeters. And then 10 plus 6 times 8 divided by 2, 64 square meters. Okay, so on this assignment, what you're going to do here is, obviously you're just going to tell me how many faces, how many vertices, how many edges it has. Right here, you're going to tell me the name of the overall figure. Like in this case, this is a rectangular prism. And then what you're going to do is find the area of the base. Now, in a rectangular prism, and we're going to talk about this more tomorrow, but on a rectangular prism, just assume the side that it's actually sitting on is the base. Okay, so like on this one, the area of this base is just 11 times 3 is going to be 33 square feet. Now, that's not going to be true for most of the rest of these. Like on number 2, well, let's talk about this one. So for number 2, what type of figure is this, or what's the name of this? It's a triangular prism, okay? So this one is actually laying on its side, basically. And the triangles are the bases. So when you find the area of the base on this one, you're going to be finding the area of the triangle. Okay? And then like on number 5, what's number 5? What is this 3D figure called? Hexagonal prism. Okay?
Yeah.
And same thing on this one. This thing is laying on its side. It's laying on its side. The hexagons are the bases here. So when you find the area of the base on this one, you're finding the area of the hexagon. Okay? Alrighty, you can get grouped up. Go for it.
What's number 4? Like, what's the shape? Oh! A rectangular or square. I'm gonna go